Hello boys, good morning. Welcome to online class. Hope all of you are well and all the family members of yours are also well, and you are just trying to keep yourself safe and by staying at home, and at the same time you will be continuing your class, your preparation, your study for because you have to attend for quiz exam on the very beginning of the February. So keep in mind that you have exam in February, first quiz exam, then very soon you will have to attend on other exams also. So just keep studying on your home. Just try to make the maximum utilization of your time. In our last class, we were discussing from the chapter current electricity, and we have discussed equivalent resistance, series circuit, parallel circuit, and then we have discussed the common terms of circuit consisting of series resistors for circuit having resistors connected in series. On that case, how can we determine the voltage from different point, or how can we determine the potential of different points? And in today's class, first of all, I will start with circuit that consists of parallel resistor. That means resistors are connected in parallel, and how we can calculate the current for different branches if a parallel circuit is given. I think you can recall one point that I have told in a earlier class, that for a series circuit, if we assume a series circuit, that means a combination of series resistors. In this type of circuit, the current, if the main current or total current is I, this current will be equal for every branch of resistor. That means for this branch, if current is I1, for the second one is I2, for the third one is I3. So in case of series combination, all the currents will be equal to I. That means for a series circuit, the current will not change for any resistor. For every resistor, the current will remain same, because there is only one branch. The current is just passing through a single branch. But in case of parallel circuit, simple circuit is given on your book also. If you just look on your textbook, then you will identify this is a parallel circuit where two resistors are connected in parallel. Why we are telling these resistors are in parallel? Because if you just look at the circuit and just look at the resistors also, the starting point of these two resistors are at are connected to the same wire. That means the point is same here, and the ending point of these two resistors are also same, connected with the same wire. That means starting point of these two resistors and ending point of these two resistors are same. That's why these are connected in parallel. And here 2 volt voltage source is used with 2 volt potential, and you are told to determine the current for resistor R1 and R2. Okay. So in this circuit, another point is mentioned over here, the potential for point D, for point E and point F, as these are grounded. So this potential of these points can be written as 0. And so in your book, the procedure that is followed is that by measuring the potential difference between the two ends of each resistor, that means if we want to say about resistor R1 এর কথা বলি, R1 এর দুই প্রান্ত হচ্ছে B and E, তাদের মধ্যে potential difference বের করা হয়েছে। and then potential difference কে যদি আমরা Ohm's law থেকে জানি, যে v সমান IR, দ্যাট মিনস R1 ব্রাঞ্চের জন্য কারেন্ট যদি I1 হয় তাহলে I1 সমান দাঁড়াবে V ডিভাইডেড বাই R1, দ্যাট মিনস 2/3 amps, অ্যান্ড I2 যেটা বলা হচ্ছে V divided by R2, just in the same way এই R2 এর দুই এন্ডের potential measure করে, because C is directly connected to 2 volt and F is directly connected to ground, so potential of F is 0, the potential of C is 2, so the potential difference for this resistor is 2 minus 0, that means 2, and the resistor here is 6 ohm, that means current will be I equals V divided by R, that means 2 divided by 6. So in this way you can calculate current for a parallel combination, but there is a problem if you are not told in this circuit C, D, E, F, the potential of these points are given as they are connected to ground, so their potential is 0. But if you are not given this potential, then how you can calculate the current just the same way as mentioned in the book? So I want to show you another technique. By applying that one, you can calculate current for a parallel circuit, and as many number of resistors are connected over here, that is not a problem. For any branch of resistors you can calculate the current. So just at first I want to write down the circuit over here that is given on your book. Here 2 resistors are connected and 2 volt potential source is also connected over here. R1 is 3 ohms and R2 is 6 ohms, and total current, if we want to measure the total current of this circuit, that will be I, and if the current is coming here, the current is getting 2 branches here. But in case of series resistor, series combination, we just got that the current will pass through a single way, but here as there are parallel resistors, the current coming here, the current is getting 2 branches. For first resistor, assume that the current is I1, and for the second resistor the current is I2. So our main motive is to determine the current for the 2 branches, that means for I1 and I2. And as I have told you in your book, this end is connected to ground, so we can easily tell that these points are of 0 potential. But in this question I'm not mentioning these points as connected to grounded, so I can't say that the potential of these points, that means that was mentioned as D, E, F in your book, so these are not of potential 0. So in this case, how we can calculate the branch current I1 and I2? We have to measure the current I1 and I2. What is the value of I1? What is the value of I2? So for determining this one, I want to tell you a single formula. IN is equals VN divided by RN, and as from Ohm's law, we can write that VN is equals I total into R total, and Rn is the number of resistors for which we are trying to calculate the current. For example, here 2 resistors are over here. First one is R1, second one is R2. If you are told to determine the current for R1, then N is equals will be 1. If for example, suppose that there are 3 or 4 more resistors are connected in parallel, you are told to determine the current for the 4th resistor. On that case, N is equals will be 4. Okay, so now what is the overall equation is I total into R total divided by Rn. So how can we determine I total? I total is equals V total divided by R total from Ohm's law. So V total is given in our equation in our circuit 2 volt, but R total means the equivalent resistance of the circuit, as two resistors are connected in parallel. So measuring R total means for example 1 by RT is equal, as these are in parallel 3 and 6 ohms. So we will use the equation for parallel combination. 1 by R1 plus 1 by R2. 1 by RT is equals 1 by R1 is 3 ohms and 1 by R2 is 6 ohms. And if you just calculate the values over here, RT is equals will be 2 ohm. That means we have got the value of R total now. So V total is 2 volt, R total is 2 ohm, and then current will be, total current will be 1 ampere. Okay, we have got the I total, we have got the R total from here 2 ohm, and Rn means for as we are determining current for first branch, that means n equals 1. Then for the first branch, if n is equals 1, then I1 equals I total. I am writing the equation again here for your convenience. I total is equals, we have got 1 ohm, 1 amps. R total is 2 ohms. R1 from our circuit, R1 is 3 ohms. That means 2 divided by 3 amps. If you just compare it with the result of your book, the result is just same as mentioned in your book. Here I1 is equals B divided by R1, 2/3 amps. But in your book, the difference is that in your book the potential of this point is given as 0, but in my question I haven't mentioned the potential of this point. And most of the cases in your exam, the question comes on questions, most of the cases the potential of this point is not given. So you have to determine your own way what is the value of current. At the same way, just like the same way, you can calculate the branch current for I2. Then I2 is equals, I total is same for all resistor, that is 1 amps, and R total is, that is also same for the using these two resistors. They have got R total is 2 ohms. But now we will write down the value of R2. R2 is equals 6 ohm. So we will get the current is 2 divided by 6 amps. So in this way we can 2 divided by 6 or 2 upon 1 upon 3. You can write 1 upon 3 also here. So in this way we can determine the current for any branches of the resistor that are connected in parallel. We can apply this equation only for the resistors connected in parallel. 2, 3, 4, 5, 6, how much resistors are connected over here, that is not a headache. We can calculate the current for any branch just applying this law or this equation. So I think this one is much better for you to measure current for any branch with parallel resistor. You can follow the step as mentioned in your book, but there is a problem. I have said that if you are not given the potential of these points, then how can you calculate the potential difference for those points? You can calculate this one also, but that is quite difficult. But you can, if you can follow this procedure, that will be much easier for you. So I think you have learned how to calculate current for the different branches if the resistors are connected in parallel, and you just know the point that if the resistors are in series, then there is a single current, that is total current will be for all equal to the all current for any resistor. And at the same time we can calculate the potential difference also for any branch of resistor. if you practice more problems related to circuit, the concept will be very much clear to you. I think you can recall one point I have told you about equivalent circuit, and I have given you homework also. I think you will have a try to solve that one, and you will submit the homework as early as possible. And today I want to say another circuit that is a very simple circuit, how we can determine the resistor or equivalent resistor for this kind of circuit. For example, here the combination of three resistors, here is point A and here is point B, and then this one is connected to here and this one is connected to here. So what is the equivalent? For example, all these resistors, this is R1, this is R2, this is R3, and all are of 2 ohms. So what is the equivalent resistance of this circuit? This is a very simple circuit. What is the equivalent resistance for this one? I think all of you guys will say that all the resistors are connected in series or in parallel. Are you confused of that? Most of the times we just assume that these kind of resistors are connected in series. But what about these wires? Wires are connected over here. Because of these wires, we can't say that these resistors are connected in series. So how can we simplify this kind of circuit? For simplifying this kind of circuit, at first we will mention 2 points A and B as given here, A and B, and look at the circuit as this point is A. So as this is connected through a wire over here, so this point will also be A here, and this is connected by a wire. That's why this point is also A. Here is B, and this B point is also connected by a wire to here, so this point is also B. Okay, if I want to mark with red pen, here is B, here is A, because this point is A, and here we have used a lead or wire to connect here, and this is also A, and this point is B. If we connect this point over here, this is also B. So now we can simplify our circuit. If we just see the first resistor here, first resistor, this is connected between point A and point B. The first resistor is between point A and B. That means this is R1. Then what about second resistor? Second resistor is R2. This is also connected between point B and A. There is no fact if we alter point A and B, but the two ends of this resistor, that means the resistor of R2 is point B and A. That means already we have connected one resistor between A and B. So how can we connect another one over here in a parallel combination, parallel way? So this is R2, and now if we just look at the resistance R3, this is also connected between A and B. So here in parallelly we can connect R1, R2 and R3. So finally we can say that these three resistors are connected in parallel combination. So what will be the equivalent resistance for this circuit? 1 by R P is equals 1 by R1 plus 1 by R2 plus 1 by R3. So you can determine by 1 by all, the value of all resistors are just 2. So you can just calculate this and can get the equivalent resistance from here. So sometimes this type of questions come to your questions, and after practicing usual type question, we will try to solve some unusual question, and you will also have a try to solve some unusual questions like this one. So I think you have understood about equivalent resistance and how to measure the equivalent resistance from a given circuit, and how to measure current for different branches. And we have known the very early concept about circuit, the elements of circuit, what are the elements of circuit that are used. And in our next class we will just try to end this chapter, try to make an end to this chapter by just studying rest of the topics. And till then we will just have more discussion on next class. And in today's class I'm not giving you any homework, just complete the previous homeworks. And in this week I want to take a Zoom class with you. What is a suitable time for you, just mention in the messenger group. And see you on next class. Till then, goodbye, take care, and thank you.